you write them down, it's just a little bit different as if you just walk by. So I want to transport my experience, and so the question and answer part is certainly important, but also certainly open to everybody. But like people like local research, in some domains they have hugely more experience than I have, and probably I can contribute my thing. And I will be showing the tool, but it's not about selling this tool to you. You would not accept this either way. Either on the other side, it's free, the tool anyhow. But I'd just like to illustrate how this could be done. So, why should I test? Well, it's just about quality. And what you discover while testing is not just performance. So, I think in the meantime, at least I found out that you cannot deliver a quality project unless you did load testing. You simply cannot. So what's interesting is the domain of capacity performance. So capacity is throughput, and these are questions like how many users can the application serve in parallel. So it's not really about how fast the page comes, but how many users can it support. And then it's about time to deliver pages, and it's also about bandwidth. And if you test this, this forces you to ask the customer how much does the customer want. And this is also forgotten in all the projects. So customers go like, I have 100 parallel users and they click at least every second. So you go, okay, fine, you build an application that does this, but do you have 50 megabit internet access? Nope, I just have 5 megabit. So we don't serve 100 users with 1 click a second. It's as simple as this. And what you discover doing tests like this is the whole stability issue of an application. So this is a classic. You do a slow test over a long period. So you do the test for like 12 hours. What happens? Application crashes because of memory leaks, server locks overflow, you have full file system, stuff like this. So basically you stuff the traffic of 2 or 3 months in a night. And it's not really important how quickly the pages come back, it's just important how the application behaves if you have the application run for 2 months. You see, for example, the recycling behavior of HTTP servers and stuff like this. Frameworks crashing. And this is, for me, rather a stability issue than a capacity or performance issue, is concurrency and deadlock. And the usual testing scenario where you go, yes, I pushed F5 and I pushed Control F5 and it works well. Well, in this scenario, you never simulate parallel users. And just simulating parallel users, you discover things like 2 people writing at the same time in the database, you have a backlog queue, etc. So you also get some information about the fitness of the infrastructure. So are all the components in the infrastructure working together, or does the application just run on one server and not on the other? And I use this very often just to reproduce problems in order to fix them. So as soon as we have a problem with an application, for me it's now rather a reflex just to deliver, to do a load test, because it's not just about load, like to do a request-response test on the application. So to produce the error, then we can fix it, we run the application again, we run the test again, we fix it, we run the test again until everything's on green. When to test, basically, the usual thing is that people test when it crashed. So this is where most of the people test. I don't exclude ourselves. And what should be done? Well, the first, this is just like a prerequisite for the test, is that somebody needs to specify what is needed. Because, like, you know, customer comes and, oh, the application is so slow. What's the definition of slow? What are you benchmarking against? Or, oh, I need to handle 50,000 users. Yeah, we can handle 50,000 users, but we need this and this hardware, etc. And then he goes like, whoops, what's the price? Okay, we go for 500 users. So there needs to be a specification for what performance do I need. And then I think the first reasonable moment is if you develop with a framework or with like pre-developed components, you may or you should be doing a proof of concept, just like glue the stuff together and do some of the critical issues. And then here you can do a first test of frameworks, where you're just building like this community application using a framework. So the customer says, like the customer I think really said, I need to handle like 100,000 users. So let's generate 100,000 users, because we don't know how the frameworks will react once there are 100,000 users in the database. So, and then here, in my opinion, it doesn't really make sense to test the application. Because if you test fragments, well, first you have to build the application before you test it, so don't test too early. And in my opinion now, it really makes test when the application is like glued together. So it really makes test to test the final application, and it also makes test to the sense to test it on the live or a very close to live environment. So don't test too early, but don't test when it already crashed. Next one, yeah, okay. Then it is release or fixed. If you once built this application, so basically you'll see you'll be building script. So when you do a new release, when you do a fix of the application, just run it again. Once these scripts are built, it's cheap to run them. And if you change something with the application, we had this case many times. Like the first release of the application was built by the database experts, store procedures, whatever. And then somebody fiddled around, and well, it didn't perform anymore. But if you find this after you go live. And the last thing of this part is where to test. Here you have like this queue of things. You may not have all this stuff, but you may have some of them. So obviously there is a requesting client, so you have an external network connecting through a firewall, then maybe you have a load balancer, maybe you have some proxy components, there comes a web server, there maybe comes an application front end, whatever, you do this in a scripting environment, and then you have an application backend, and you have a data container. And between these elements there are network connections. Now the question is always, yes, where to test? Should I start with the database first, or should I look if the firewall performs, etc.? And I always test here. So I regard this part here as a black box. Yes, there are scenarios where it makes sense to test here or here or here because you want to know the performance of the backend, etc. But the first point is just to find out what's happening in the application. And so you need as little complication as possible. So for me, in my opinion, don't test the environment first. If you have a problem, you can test environment. But if you begin testing the environment, you fiddle around with TCP packets, you tune a 0.5% of performance out of the application, but probably you have here something much more serious to tune. So I treat application as a black box, and only when there is an issue. So because most of the time you have a ranking and it's like one request eating half of the performance and 100 requests eating the rest. So you don't have to figure around what you have to do, just like fix one at a time. So if there is an issue, then I look into the black box, or then I change the point of measurement. So my point is not that you shouldn't test here, but you should test here when there is a reason. And you can't test everything, otherwise you test for weeks. And a word of caution is this happened more than once. Load testing generates load. So don't test too easy a running application. Or like, yeah, let's do a load test, and then you go against a live site. And it happened more than once that I killed live sites. Because I just went like, it runs on the development environment, so it certainly runs on the live environment. So I had some stories here. Okay, choose. There. Yes.
Maybe in the spring, could you go this?
Yeah.
So I don't take too much of the presentation.
It's all about fanning. So there are millions of tools. And I don't want to go into a tool discussion, I just show you 3 tools I use on a regular basis. So one you may know is Apache Bench. It's a very small executable that basically helps you hammering on an HTTP server. You give one URL and you say, please generate 50 users and go for it, and then it does a percentile statistics in the end. So it's a very easy, very stupid program, but if you don't pass this test here, you don't have to do the rest. So if your homepage comes like twice a minute or so, you don't have to think about the rest. What I do very often, but I'm not so sure about the result, the Firebug extension, like you just go for F12 and you do control reload of the page, and then you see all the elements of the page, you see the XML HTTP requests, you see how much these take to load, how big they are. So if you look in there, you see, whoops, there is a JPEG 130 kilo. Is this reasonable? Yes or no? Or you see I have 200 page elements. Is this reasonable? Just looking into Firebug on an application makes you understand some things about the page. What happened here often, for example, is that there is a page element that generates HTTP error on the request, so HTTP 500, and you don't see this on the page because it's sort of like an old element that's not used anymore, or a CSS that requests a file that doesn't exist. And you don't see this on the page, but you see this in the Firebug extension. Or you also see there if the browser requests the FAV icon, and you don't have one. So it's just 1404 too much. You could eliminate. It's little stuff like that. And what I'll be showing now, the following is a tool called Proxy-Sniffer. I like this tool because I know the guy who programs it, David Fischer. He used to work for Post-Finance, so he's very solid about enterprise applications. He was responsible for security there, responsible for the whole e-banking. And he just now does this tool. And there is a free version, and the limitations of the free version, it just does HTTP, so no SSL. It just generates 60 users in parallel. Most of the time this is sufficient. And a maximum test duration of one test cycle is 12 minutes. And in the version you buy, these limits are not there. What's nice about the tool, it's all browser-based, on no plugins. And it just needs Java, larger Java 1.4. And so it runs on all the Unixes, Linux, Solaris, etc. It runs on Mac and Windows. The installer just runs on Windows, but it's contained everything in one directory. So even on Windows, it doesn't fiddle around with the registry. Just take one directory and it's everything in there. And you'll see it's very flexible. So now I'm going rather directly to, so basically everything I'll show you is in two files. If you, for example, do a deployment on a Linux machine, you just need a jar file, Proxy-Sniffer, and the key file. If it's a demo key or a license key, doesn't matter. And with these two files, you have all the functionality I'll be showing you. So it's rather stupid. And it has clever documentation. David built a set of PowerPoint slides that walks you through the process. So you don't have to read text, you just can look at pictures. When I launch this Java application, there are millions of command line parameters, but if I launch it on default, the application then listens to 3 ports I'll be showing to you. So one is an administration port, that's basically the graphical user interface of the tool. There you do the recording of the session and you see the stats. And then there is a separate port I can deploy on other computers. Is the execution agent. This is the software part that really does the test. So I'll be explaining like the details a little bit later, but this part is separated. So I can put these execution agents on multiple machines. They have the GUI on one machine and the execution I do from as many machines as I need or I want, either to generate a network architecture. And this is a nice part. The tool includes a proxy, and I use the proxy to record the session. So I'll be showing you how to record a session. So I start the tool, and I point one of the web browsers to the proxy. And so the proxy records everything that goes through the web browser. And this is my scenario. So it's very easy to record scenarios because you don't have to do the scripting. You can record it, and only the parts you want to change relative to the recording you have to script. There are some more ports not really relevant. Yeah. So it's about recording a scenario. This is for documentation. You look at the scenario, you can adopt the recording. You don't have to stick to the recording. You can fiddle around. And this is now a nice. So this here happens in the administration GUI. And then the application generates a test. And this is Java code. It's lousy Java code, but at least it's Java code. And you can change everything in there. So if the tool doesn't give you the flexibility you need, you just go into the generated Java code. And there you can do everything if you need to, whatever credentials or certificates or what we did also, if you need to adopt a test, so you record a basic scenario, and then you write some scripts that change the Java code. And then you can multiply the scenarios without fiddling around in the GUI. You generate this, and this class here contains everything the test needs. So all the information about the servers, the libraries that do the HTTP communication, so it's everything in there. And this is also the how many users to generate. No, this is done later. And now this test component, this class file, is the only thing you need to execute the test. So you take this class file and you run this class file wherever you want to run it, either synchronized or so. Then blah blah blah. So. So I now started this Proxy-Sniffer console, and you don't. It just built a Swing application around the command line. So you don't really need this console here. It's just a way of nicely wrapping it. This console doesn't run on Mac either, so there you just do it on the command line. What's nice here, you see like all the comments that have all the commands that have been done. So the whole environment, you can script this on the command line easily. So he delivers some tool to make it easy. And here you see now, well, WebGUI is ready on port whatever. And you see here the execution is generated on this port, the admin server on this port, etc. So it now started the application. And now what I do is, so the first thing I can do is 7990. So here I use a Firefox now for the GUI. This is the GUI of the tool to do the whole stuff. So I generate this browser to like use the tool, and I generate an Internet Explorer to do the recording. So in the Internet Explorer, everything I need to do is I have the request go through a proxy. So I say in Internet Explorer here now, please use a proxy on localhost on my machine. And this is now the server that has been deployed. So now this Internet Explorer goes through the proxy. So this proxy here doesn't do anything. This is how I started it up. And when I now request a page, it goes through the proxy here. So you see the requests, it numbers the request. And you also can look at the single request. So here you have all the request response pairs, etc. So now I do first, what should I be recording? I really think about what I should be recording. I do a first test on the web. So this is everything part of the documentation, but I now use Internet Explorer to record the test to have a behavior of the client that I see in the proxy that's close to most of the users. So I could do the recording whatever browser, but most of the time I take Internet Explorer because like they take most of the market, and all the caching behavior of the client, etc. is just like Internet Explorer does it. And when I do the testing, I do the most pessimistic scenario. So the first thing I do in the Internet Explorer, I delete the cache, because if I would be recording the scenario now, I go back to the dynamics web log. Well, most of the items are already cached, and I don't want it. So in the tool, I'm back in the tool, and in the tool I say, okay, now I want to start the recording, and now the tool listens to the proxy, and I say, okay, I do my first request. I can do section breaks. I do the homepage request of the weblog, and then I go on a category, whatever, accessibility. Here, and that's it. So I stop the recording, and now in the tool you see the single requests that went through the proxy. And here are the section breaks. I did 2 section breaks. Section break 1 is homepage and label. And section break number 2 is Oh, there is an inner frame. That's cool. Okay. So, and this is category access. And now the first thing I have to do is like to go through the scenario and to look if it's reasonable. So for example, in here, we have a Flickr badge on the page. Do I want this Flickr badge in the scenario? Maybe I want it, maybe I don't want it. I can delete this item in here. Blah, 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 blah. Here come more Flickr requests. I think I should take them out 7 to 9. So now what I do on one side, I change the scenario that I want to test later on. On the other side, I also get the first insights of the page. So there is another technorati embed I don't want. This is a lousy site to test. So there is some. Okay, another technorati, blah blah blah. I think one of the disadvantages of the tool is it likes Windows. So. Okay, so now this looks reasonable. So there is more Flickr here. Analytics. I take some more requests out. What you see here in this first recording is also the timed behavior of the page while recording. Flickr out again. So the first thing to do is just to look at what has been recorded. So in here you see all the requests. So do these requests make sense? Do the content size make sense? Do the response time make sense? You can go on a single item, and you have the recording is very complete in terms of there is the header, there is a preview, etc. So I don't really go into this because I first want like to go shortly through a test. I can save this scenario. I don't even have to save it. Oh, I save it for completeness. Huh? So I save the scenario, calling block, and then I generate a test on it. There is some, you see here that you can do basic authentication, NTLM, you can use certificates. So there is, you can define some header stuff you want to check, but I just go through it once. Okay, so what happened now? What I did now is I did recording of the scenario. This is the Proxy-Sniffer tab. This is the recording of the scenario. This is quite huge because it keeps all the information that comes from the proxy, just that later when you, while analyzing, you have the details. So that you don't need this anymore. And this is the job, this is now the test completely with everything in there. So I told you it's lousy Java, but at least you can edit it if you know to push the right. Okay. So this is the code that has been generated by the load test program. So there are all the contained libraries, and it's stupid. So here comes my first page break. It's called home page, log entries. Here comes my first request, log entry, blah 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 blah. So because you have this in hand, you don't really have to ask if the tool can do something, because lately in here you can change whatever you need to change. But you can do a lot of things without changing it. So I use this, I take this Java and I generate the code. And here you see now a window popping up. You see all the OS commands that the program submits. So if you want to do a script that does all this stuff, the program tells you what you have to do in the script. Okay. So, and I now have here the class file, and just like to make the story short, I can submit the first test. I execute the test now from the local execution. The time I started the server, I have a local instance of this testing facility. How many users, how long, etc. So if you want to know more, so we can start a test with 5 users. And again here you see the command line that's being sent to the test. And now, what's happened is that this test class is detached from the service and is sent to the execution agent. And the execution agent then begins running the test and sends statistics data back to the GUI. But how often this statistics data is sent back you can configure. You can also run the test and say, I don't want to see the test again. For example, if you do a 24-hour test, you don't want to have 5 seconds update. So this, again, here you see it's everything in here. So you have the test called block, minus U5, 5 users, minus D duration, 60 seconds. The statistics delay, 200 milliseconds, max loop, etc. So it's quite stupid. This is all declaration. So now this test is completely detached from the GUI. It's being executed and it sends back to the GUI. And you can try to interpret some things in here. But interesting is here, certainly this here, session failures. This is also one of the learnings. When the transaction time really goes up, then look for the session failures, because this is one of the things, like if the machine begins reporting HTTP 500, well, most of the time they come back quicker than HTTP 200. So transaction number could go up because you have session. So here you see how many users, concurrent users are simulated. There's a short warm-up period I can define, and a cooldown period in the end. And so I executed the first test, and I take the test back from the exec agent. So this is my first test, and I do a second test just to do some analysis. So I do 10 users. This is the second test now I'm running. So again and again. Now the terminology of the tool is, so like there are web transactions. So basically web transactions are a hit. And the scenario I've recorded is a single line. So how many web transactions you do, it depends heavily on your scenario. If you do a lot of static requests, I don't know, you get base page elements such as JPEG, CSS. Obviously, you generate a lot of transactions. So these numbers here, they don't tell you a lot, but you can look here, for example, keep alive efficiency. If the keep alive is being used, this information is certainly not correct, but because there is a keep alive efficiency here, 260 URLs calls are done until now, average of 5 transactions per second, blah blah blah. So we have now 10 users, and it finishes all the loops. So there's a cooldown period. We go to 9 users, 8 users. This is the reason why the test may not take 1 minute. Now it's 1 minute 06, because it warms the system and cools it down. What I do now is something that I said I shouldn't do. I test through the network. So the application is in St. Gallen, and I test through the network. This is why I get so lousy results. I'll change this later on. Okay. So now here I have the 2 tests I run. So the tests run at this time. One's generating 5 users, one's generating 10 users, blah, 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 blah. And now I can begin analyzing. So there is a lot of analyzing functionality in here. For example, here is what's the average session time per user? With 5 users, with 10 users. So average session time really increased. So these are lousy results, but it doesn't really matter. Web transaction rate, this is also a lousy result, because at 5 users I had like 5 transactions per second. At 10 users I had less than 5. So an application that looks like this it's really crap. But this is what I told you not to do, because the application is a static application. So what I do is I request static files from an Apache. So the bad results I see here, it's just bad network. So what I showed you now is probably a little bit like too easy. So we could become, or we can become now a little bit more complicated. But again, just doing something stupid like this really helps a project. Just understanding what are the requests of the page. Do all these requests come back with an HTTP 200? How much is the efficiency of the caching? So there are more information here, but what I do now is, until now I have tested out of this machine. So now I deploy a test environment on a machine close to the machine I have been testing in St. Gallen. So I access the machine in St. Gallen. Now this is also nice, the application doesn't need, I should start copying class. So what I told you, I need just two files, the Proxy-Sniffer key and the jar. So, and now I deploy this to a machine that's close to the machine I want to test in St. Gallen. And I just need these two files I have mentioned, and they're like, was it? That's a real. I've been testing through this pipe, so this should test. This will change now. The nice thing is that on the target machine, you just need a Java. You just need Java, and you just need write access to the directory you're in. So I'm now putting it in the temp directory, so I don't even have to be a root user or whatever. And even in complicated environments where we use it, like banking environments, we were able to run it on the machine. So basically what you need is Java, something like this. So here is even like an old version of Java running on, but it doesn't really matter. So when you run this, I have, what is another cheat sheet? Here's my cheat sheet. So I have to do two things. I have to include the jar in the class path, so the Java application runs it. So that's easy. And here is the command to run it. So as soon as it's here, I run this Proxy-Sniffer jar, and now here I just run execution. I don't need all the ports, I just need one port. Now the communication between this machine, I have it here, yeah. The communication. So I run this, and here, this was quick, it's not a huge machine. So here, this is basically the same log you saw in the swing window I showed you before, but just with less stuff here. So I run execution, and it's ready on the port. And the tool is very clever. The tool is very creative in finding its ways, so the execution can talk to the GUI. So even in quite complicated environments, most of the time it found a way back. You can either do socket communication, but you can tunnel it in HTTPS or HTTP. So it's quite easy to get back from the testing server to the GUI. Now in the GUI, you don't have to do a lot. In the GUI you can define that there is an additional blah blah blah. Oh, it's here. So I have this execution, I run a test on it, and that's it. So I defined the machine name where it's running on the execution, it's on the default port, and I pushed the test, and here I have a response from the execution on the remote machine. And nice again here. No, it didn't say anything. I thought it would. So I defined a cluster, a test cluster, going around, and this is everything in the free version. So everything I'm showing to you is in the free version, so you don't need to spend money for it. So, I have these cluster members in here. So I have a cluster called test with these two members in here. And now we go back and run the test. Now let's generate 20 users or whatever, and please run it on test cluster. And now I can say, okay, let's generate 5 users here and 15 here because I know the machine is stronger. Okay, and now starting the cluster job, the class file is being deployed on the 2 executions, and the GUI in this case synchronizes the executions. This is one functionality of this jar file, that it can synchronize tests. There is no limitation on how many executions you have. In our company, because some of the people work with these tools, you just need to tell somebody, please open the tool. It automatically opens an execution, so it's very easy to access multiple executions. And now here you see web transaction rate. It's now swinging up to 100 a second. So yeah, obviously it was because of the network. And here also see that the local execution has like 8 megabytes. It's really bytes. 9 megabytes transferred, and the remote has 160 megabytes. So, and what's really nice in the handling is that, for example, now because of the reason I work on a cluster job, it doesn't change the handling of the tool. If you do the scripting, again here you have all the script parameters. It doesn't change the script parameters either. So it's like a tool written by a techie for techies, and not there is no marketing department that defines the blue borders around it. Obviously not. So, and now it's getting the test results now here on the machine, on the remote machine. You see here the commands that have been deployed on the machine. It builds a directory where all the test results and the tests are on. So it's very transparent. You leave it on the machine, you remove it, you can copy it back to archive. That's very stupid. Here, acquire results. While I was doing the test locally, it didn't make a lot of sense that I have an acquire result button. Now it makes sense because one of the test agents is remote. So it gets the tests back. Here, I want to get this result set from these 2 execution agents. And now you see my load curve here, transaction rate going from here to here, etc. So these results doesn't make too much sense. But I can go into a single test, and there is really a lot of nice information here. For example, I keep alive efficiency, how the network sockets were reused. Obviously, top consuming URLs. So it's not really nice what you see in here, but you see a lot of information. So here, there, for example, test scenario, blah blah blah. So again, now this is the killer feature if there is a business consultant. There is this report button here that generates a PDF report of everything. It's just this is just a magnificent tool if you offer the customer like 2 days of load test, and it takes you literally a half a minute to generate 20 pages. It's really a gorgeous feature. So you can go, wow, and you see this, wow, there, and it really doesn't make a lot of sense, but it's just, it looks nice, and it's PDF. Now, I could go more complicated now in this. Obviously, there are a lot of parameters, and you have input files, and you can randomize scenarios and so. But I don't want to do this, but like finish the presentation and open for discussions before I do many more demos. Oh no, some theory. No, I think this is like a surface, and you have water, you pour water on the surface. So because the surface is open here, you can pour as much water as you want to. So if you pour a little bit of water or a lot of water, the pass-through time of the water, if you measure it here, doesn't really change. It changes a little bit because of the weight. But this here is a linear system. So if you look at the plot, like the plots I've showed you, so the throughput, when you pour more water, there's more throughput because there is no limitation. So this is a scalability curve you'll never get, obviously. The pass-through time, so how long the water takes to go through, is also linear. So it doesn't matter if you have a centiliter per minute or 100. So this is for advanced heat. If you have something that blocks the water, so it's like this is now a tube. So what happens here, obviously, there is a point, I call this where the maximum capacity is reached, because like this tube here just allows to flow a certain quantity of water. So then the load curve looks like this. So here it scales linearly unto a certain point when the tube is full. And in an ideal world, okay, we don't have Stuker, etc. Then it just sticks there, and the pass-through time of the rest of the water gets larger because you have a backlog of water in the tube. So this is, if you have a load curve that looks like this, it's okay because you understand that, well, this is my limit. Usually it looks like this. And I don't really have the water example, probably if you put a pressure brake, but usually if you put more and more water, there is a point where the application collapses. Because obviously there is a backlog queue of HTTP requests that can't be served. So who takes the backlog? And there is a moment where you have too many instances, too many memory. It's a question of time, how the application behaves here. So I call this here, this is like, the system begins to collapse here because it doesn't behave rationally, because it's worse than before. And here usually the system is blocked or F. Yeah. And pass-through time, here it goes to indefinite because some of the requests will never get back or run into timeout. So these are now results from real tests. So this is what you see here is the capacity. Here is the number of seconds the whole scenario takes to get through. So a recording of many requests. How many seconds does it take to execute the scenario? The red line is the minimum time of the scenario that could be reached. Why minimum time? Because there is user think time. So between each of these sections, I call the home page, I call a section, I have a think time. So the user says like, I click this, I wait for the response, I wait 3 seconds, I click again, I wait 3 seconds. So here if the think time would be 5 seconds, 25 seconds, I have 5 request blocks multiplied by 5 seconds. So here, if I simulate 5 users, it takes 20 seconds to deliver. If I have 20 users, it takes, there's 24 seconds exactly. And here's the web transaction rate, that is, you have the number of users and how many transactions or hits can be done. And this is like a very clear scenario that the capacity of the application, here it goes horizontal, so the application doesn't scale anymore. So between 10 and 20 users, the application gets faster because there are more requests. But 30 users, 50 users, it's the same. So here, this is the capacity of the application. The application obviously doesn't take more than 50 users, 20 users. And here, this is the really ugly part. These are the session failures. And I see that 10 users, 20, 30 users. And the moment I simulate 30 users, I begin with session failure rates. So this application just doesn't scale at all. It doesn't scale in terms of getting faster with more users, and it doesn't scale in terms of more users and being stable. So even so, here, this is the network throughput, generating 20 users, it has a 12 megabit throughput. So again, if the customer is like a 10 megabit internet access, or even worse, a 2 megabit internet access, you say, okay, it's a bad application, it doesn't scale. But you have a 2 megabit access, so we don't really have to care about, because you always deliver down here. You will never deliver up here. So even so, the application is no good, you will never have this kind of traffic. The problem is a little bit too bold, because you may have concurrent users. The same application here generated a throughput of 85 megabit, when you request cheap pages. So this scenario here has expensive pages in it, the application, and this now is cheap pages. This is one of the tests. I just request a 1 megabit JPEG file, and they'll say like, how much does the server get? This is interesting when you do it for a long time, because very often you see like syncs, for example, file system syncs or background jobs. It's interesting to have something like this run half an hour, because all of a sudden you see like every 10 minutes the system breaks down, and the sysadmin goes like, yes, you know, every 10 minutes we do this and that. And this is also a classic. These are all original NAMS projects. We fixed before we delivered them. 5 users, wait time 80 seconds. 10 users, wait time 90 seconds. 15 users, wait time 20 seconds. So, oops. And web transaction goes back. And what happened here is that we got quicker because the application threw errors. So here it's obvious. don't misinterpret the results. And this is like a nice application. So here, web transactions, you're very close to the minimum. Adding more users, 15, 20, 25, the application goes up and up and up. With 50 users, it does 160 transactions, so this is nice. Network throughput, it's not very high here because obviously you request small pages, it's 5 megabit per second. Network connect. And there are millions of graphs like this in here. And it's basically, in the end, it's experience to interpret what to do and what not. So, I try to put a little bit together what I said. So, what's really tough, and probably the toughest thing, is to get a correct scenario. Now, on my weblog example, I click the home page and on blah, 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 blah. It's very easy to choose scenarios that scale well, and it's very easy to choose scenarios that don't scale at all. But are these scenarios realistic? So, do you test something that's really meaningful to this world? And this is indefinitely complicated. But like, there are 3 hints. So one hint is you look at historic traffic. So you just look at statistics or log files. If 70% of all the requests go to the home page, well, your scenario should do 70% on the home page. And if 0.5% goes to the search, don't do 20% on the search, because historically, obviously it was sufficient. So always a safety margin. So you say, okay, we want to deliver what we delivered before plus X%. Then ask domain expert, ask business people. Don't ask the techies what to test, but ask the business people. So if they're building an application, an intranet where the user should be able to do this and this, so take the most meaningful stuff. And here you have to use ask the system owners, not the techies, because the techies, they like to test details, but it's not about details, it's about processes the application should do. Or take user stories or use cases in the specification. And the best thing is, if there is money involved, follow the money. So in the shopping applications, if it's about selling something, test the selling stuff and not the recommendation stuff, because there it will really hurt you if it doesn't work. So in terms of priorities, go there where the money is. What to test? I'd say in minimum. So what is the bandwidth issues? This is a small item, fetch it again and again and again, just to see how much does the server deliver? 1 megabit, 50 megabits, 100. So is it stable for 10 minutes? Every server should be able to do this. If this can't be done, so you don't need to do the rest. And then it's a number of transactions. So you do short test cycles. It's not, you don't need to have not. And you go over like 5 users, 10, 20, 40 users, and then you are able to generate this load curve session. So basically you just want to find out where the system levels, so where the transaction rate goes horizontal, or if it goes up and up and up, or if it decreases, or it crashes. And so this happens more often than not. And the last test I would propose to do is like this long runner test, because the issue of as I told before, memory leaks, etc. You see this after like 1 million requests and not after 1 minute. And nice to know, but this is like the things you should do, and this is the things you can do, is try to start the system under load. This is very funny. Or try to stop the system under load. And the question here is, does it break? Especially stopping systems under load can be very ugly on the database. And another thing, if you have a redundant infrastructure, try a degradation test. So you have a cluster with 3 front-end servers, etc. You do load test, everything's nice. Take one out of the cluster nodes, just to look, how does the load test behave? Do I stall for 10 seconds, or does it just go through, etc.? So, watch out for, these are the pitfalls. Well, a realistic scenario, what requests, how much time between the requests. Look at write. Everything when you write to an application, it's obviously much more expensive, so don't just do the cheap get stuff. If you look at log files, well, don't forget the post requests to the application and the content that has been transmitted in the post. And care about caching, so you have to be as close as possible to reality. If you, for example, you test with a browser that has cached all the page elements, well, normal user will not have 100% caching efficiency. Then, if you look into the system, before you ask yourself if your test is meaningful, go for 100% CPU of the tested system. For example, the first test I did here, I didn't get a good transaction rate because of the network. I just looked at the CPU of the application. And while I was doing my test, I didn't get more than this, like 6 requests per second, while CPU of the application server was doing nothing. If I don't have any CPU load, I have to think about my test, because if I don't stress any component, where is the stress then? Look at the database. If there is a persistency layer using a database, just take the slow query reports, and there most of the time you have like one query that kills everything. Look at the response. The response during the test. Here the tool gives you some alerts. There are some mechanisms in there to test if this is meaningful. But this is again for the application begins to deliver HTTP 500. And all of a sudden you get nice transaction rate because the errors being delivered back. And this is very tricky because I have more than one applications that deliver HTTP 200, a database connection, not 500 or something like this. But it delivered it using HTTP 200, so it looked swell before you looked in the response content, and the response content was correct. Does the system that executes a test deliver the load? I had this problem here because of the network, but you have to look also on, especially if you have multiple users on Windows, if you want to open like 200, 300, 400 sockets. So the test that you're executing, you need to execute this probably for more machines or from a Unix machine because this couldn't handle it. And well, then look at the error logs of the application. Just what's in there, because from the outside it may look nice, but you have a lot of stuff in the error log, and latest when you go to production, people look at the error logs, and if you have then errors in there, they don't like it either. And where are the problems? This is like a slide between David Fischer and me, and I did enough tests now, and I think more than half of the time it's a problem of the application code and or configuration of the application. And very, very often people go like, yes, well, we have this network connection that doesn't work well. Most of the time it's just here in the application and not in the rest. So, and even if it's, I don't know, if it's firewall something, it's not about huge sums. The firewall, I don't know, loses 1 of 1,000 requests. This is not nice. But if you have in your application pages that need 7 seconds to render, so you don't have to look up here. So we can discuss about this if this is reasonable. So okay, if the firewall loses packets, it's not too nice because you have these error messages nobody can read. So I'm finishing, unless you want me to do that. So for me, load testing must be part of every project plan. I think it's one of the most meaningful tests, you know, like these scripts doing if the functionality is okay, yeah, it's nice, but if the application doesn't deliver or crashes under parallel users, it doesn't help. The product owner must define what's needed. If the product owner comes and says we need 5,000 users and so many requests, well, like, okay, this is the price for it. And most of the time, it happens that the product owner never says what he expects. And then it's always too slow and it's always too less scalable. Don't test early in the development cycle. Yes, it's just a matter of complexity. If you begin testing too early in the development cycle, you're losing time. First, you have to finish the application, and when the application is running, you can try to optimize it. But don't optimize the application during development. You know this. So, test as close to the application as you can get. This is to be discussed. I think percentile statistics are okay, so you don't need 100% of the requests that perform well. So if you look at the distribution of the results, like say like 80% of all the requests have to be delivered in 200 milliseconds, and 95% at least in half a second, and they don't care about the rest because there will always be slow requests in most of the applications. Scenarios are tough to get, and before you do a lot of fixing validated test results, so it happened very often that, I don't know, something was wrongly configured or that the application delivered something. Yes. Now, am I wrong? So your opinions or questions? Yeah, of course.
Does the tool respect my robots.txt?
No. The tool, it's not about crawling or something. The tool doesn't respect anything. It just records what I do.
Yeah, but can you DDoS the site with that?
Sorry?
Can you DDoS the site?
Of course.
Absolutely. Yeah. This is what I said. Attention. It's very easy to take a site down because this class file is self-contained. So as soon as I have a machine running Java on it, I can run this test and can synchronize it.
easy too.
Yeah, but this is you can use Apache Bench to take a site down. Yeah.
JavaScript. Well, I'm trying to understand exactly the request it generates, whether that whole
the proxy records everything that goes through the browser where you do the request recording. So, for example, if this browser has a Google Toolbar in it, you see the request of Google Toolbar, etc. So, even HTTP requests, they are recorded, and it works nicely. It's a little bit more complicated to make them dynamic. To make a HTTP request dynamic, it's easy. There is a functionality in the tool where you can map request parameters to text files. So don't execute the test with the same request parameter, but use random out of. And HTTP, XML or JavaScript requests, you see them in the proxy log, they're recorded, they're executed. It's a little bit tougher to manipulate them. Yes?
What about session keys?
This is the same thing. Or I could be showing this. I can show this just as a principle. So here is this is a stupid recording. I have to record something where there is a key. So I go. For example, here I do a search on an internal search engine. So what I did here is now I recorded some more requests, and one of them now containing query parameters, and there is no session key, but it's the same principle. And I can go now into a single request, and I can map these informations to text files, and also when there are session keys, I can take the session key. There is basically, it's like here are hidden fields or request parameters. I can push on a request parameter, and then I can assign this request parameter. I can say generate a new session ID every time you do a loop, or generate a session key for every user, or so even using click and click here, this is very easy to do. Got one?
I'd like to present an alternative to a lot of work, because the main problem with this is finding scenarios. Like you said, it's very hard to predict how many users there will be, how many, what kinds of accesses they're going to do. So even if you do load testing, you still don't really have a guarantee that you will be able to maintainable. Usually you have a very good chance, but it's no guarantee.
Fair enough, yeah.
And the way we try to get around even having to do load tests, we are in a special situation though. We are our own customer, we can do that. You cannot do that when you got to guarantee your customer in advance you can hold this and this load. And it's a completely new application. All this doesn't happen to us. So we get around having to do load tests by just monitoring latency during development. That's very easy. If you can see your single page request, it takes 300 milliseconds, that's fine. 1,300 milliseconds, no. Check this. Work on this. And the moment we launch, we don't announce. So we just use our users as guinea pigs, basically. If the load goes up too high, we just revert to the previous version, keep working, analyze the log files, which are realistic log files. Analyze log files, what went wrong, and fix only what's necessary to get it right. Not to fix something that's only necessary in an artificial scenario that may have been a little bit off. Other tricks that you can use is launch new features only to a certain percentage of your users. That's what we do from time to time when we do big stuff. We use a range of cookies. We have an ID for every user, and let's say 10% of our users get the new version, everybody else gets the old version. We check, can we hold the load this way, and then we can up this percentage until we're 100%. Often this is also possible by putting all users with the new feature on a separate machine. All our applications are load balanced. So we just update one machine, make sure users who see the new version only see the new version, always see the new version, and then we can analyze that one machine. What's going on? Oh, this does a lot of, for example, disk load, for example. We do too much disk I/O, we have to work on our application. Let's get back to the old version until we got this fixed. And the last trick is we usually launch during off-peak hours. So we got a lot of headroom the moment we launch. It's about, we always have 3 times more capacity than we need at off-peak hours. So if our new version of the application is 3 times slower, no problem. We can hold it by throwing hardware at the problem, but we can see we need to fix this before we get into the next peak hour. Otherwise, we have to revert. And the last thing is we release small features very often. We don't do very big changes at a time normally. So whenever we have launched a small feature, it's not a big deal to revert that small feature because it turns out to be very resource consuming and needs to be worked on still. So load testing does make a lot of sense when you have a customer to deliver to, but you can very often get around it when you are your own customer.
You're like sort of a wrong person for this presentation because I agree. This is what you say, but very often you have to deliver to the customer. Even we're not allowed to touch the live system.
Yeah.
You have to deliver the application with the documentation and. You can't revert features, but I agree. There are many other ways to do this.
I'd like to know how about caching in that Proxy-Sniffer tool. Does it simulate browser cache as well? If you have about 10 concurrent users and they click about 5 pages, does it really read the headers of the static files and does not request them anymore in the next request? Or?
No, it doesn't interpret anything. It just reproduces what's in the scenario. So, for example, if you do something, if you want to be more realistic, you do a recording of one scenario with empty caches, where you have all the cacheable elements in there, and then you save this, and then you do a second scenario where the caches are filled. And while execution, you can say, okay, take 5% of this scenario and 95% of this. And this you can easily then mix scenarios, or say generate 100 users with this scenario and 5 with this scenario. But the tool doesn't does any interpretation. It gives it to you.
How well does this agent scale? Like, what was the biggest test you did run with one server or one Linux box?
They scale very well, because all the libraries in there were written by him. So on the machine like I was running on now, this live is it's quite a crappy machine. It can generate something like 500 requests per second. So they're quite efficient stations.
Yeah, did I understand this correct on the homepage that he sells it CPU based for a fixed price for a CPU, but for every agent you have to buy the same license? Or
I don't really know how this model is.
I mean, it has a second line like side license, please call.
Yeah. I don't really know about the license.
Okay.
It is very. For quite some time I have worked with the free version, because in most of the cases the free version is already very meaningful to what you need to fix. And because I know him, he gives me the license.
That helps.
But this CPU-based model, I don't really know how he counts the CPUs.
Yeah.
Maybe you can just convince him.
No, but this is really one of the nice things if you have the developer here in Switzerland. So even if you meet him on site, from time to time we take him along to the customer, because it's like a neutral party, and he always has a source code with it to make the thing more stable. No, I really like this software. It is very stable.
What is? Are there comparable tools? I mean,
There are millions of tools.
but
So
I mean,
there-
I've always looked at stuff like AV and
We in MS we were looking at some. On one side we were working with commercial tools like Mercury Test Runner, because the customer wanted these tools, not because we wanted them. And they're just too expensive. So they can do, most of the time they do less than this tool here, and they cost a fortune. And on the other hand, there are a lot of free tools around. There is also from Microsoft Notch2 a free tool that's not too bad. And I don't really have a market overview. I fiddle around with some of the tools, but since I'm working now with this here. But I think this is something back, who does load testing using other tools in a room? No, go for it.
Yeah, I used to have to window from a German guy. But it was cool because you could do the stepping automatically. You said, yeah, step up, like test for 5 minutes with 5, then for, and he did the automatic stepping. So at the end you let it run for an hour and you got your beautiful PDF at the end, which you could deliver to the customer.
If you need to do this here, would need to do a script that executes the test. So not in the GUI. Other tools?
Well, we haven't done such sophisticated tests yet.
It was not sophisticated yet.
That was easy.
Well, last weekend I used HTTPerf. It's like Apache bench, where you I took some URLs from a log file and feeded them into HTTPerf, and then measured it like this.
Other test tools. So little people doing load tests. How will your applications perform? Very often using this test we find very basic errors in the application. So it's not really about you find configuration problems where some content types are not correctly. You find that I don't know GC doesn't work. You find 404 errors, etc. Just like to do this test for half an hour does really help you to understand what your application is. So I do now more against
Stories.
Well, I think we didn't do loads performance testing so far, but I just for a new product we're going to launch soon. I think we're gonna try this tool tomorrow. So for the first time.
Got scared.
What I really like is that it's a very stupid but efficient documentation. There is a Java doc of the whole API, etc. So, but here there is a documentation that it's really about click here, push here. Everything I showed you, it's really, you don't need to read a lot. So even for complicated stuff, it's very nice. You do this and then you do that. So I think it's very pragmatic.
Yeah, I think the history is really good. I mean, it's like when someone else came along and fiddled with the code and broke something.
This is something. This is a nice learning that's integrated in the. I skipped over many of the dialogues. When I generate this load test, there is what he calls a content test algorithm. So here, while executing the test, he automatically checks the response. And the heuristic, there are two heuristics in there. And one is test checks the content of the response page, and you can define what content. So by default, it's like the first few words of the page. So as soon as the content of the page changes, you get an error while executing the test. And the other heuristic is that the response while executing the test is plus or minus 5% of the response size while recording the test. And this is something very stupid but very efficient for if you have a portal application and because you do less tests, like one of the portal elements doesn't deliver anymore, you find this using these tests. So this is something there. I think there is a lot of you can like switch off keep alive to see differences. So there is a lot of small information in here in the tool, and just the fact that you look at the dialogues like this make you think about your application.
Just another small thing, which it's years ago, but I had a problem with, we had to test load scenario with XP boxes. Well, who uses XP to test load test? Anyway, but we figured out starting SP2, Microsoft reduced or did limitation to the TCP/IP stack. So there is some kind of limitation that your XP box cannot produce more load. I don't know if that's still the case with Vista, but they did so because of the whole virus stuff. They did reduce the set of possible TCP throughput on the socket. So use Linux, then you don't have problems.
Oh man. But I think that was a registry key.
Yeah.
You could
you
fiddle
can
along with.
revert that, I guess.
It's
if you know how to.
it's in the documentation of the tool.
Okay.
You also say like if you don't get enough throughput during the test, Windows machine try this. It's like the.
You know?
I think so, yeah.
But what about this?
What about?
I thought you had anecdotes.
Yeah, like some anecdotes are in here. I think like read the most important stuff is that okay, we are like in this deliver projects against money, so we're not like we don't own the stuff. So most obviously it's very important for us that the customer defines what he expects. Because applications are always too slow. It has to deliver like Google, but yeah, Google doesn't have one machine. This is like, and this is what happens like all the time if you don't do something like this. And again, the reality is that when you put the application together, always stuff gets wrong. And doing something like this, the most, I think what we discovered most, in the most cases are bad SQL queries. This is what you discover easiest. and you have them in all the projects, even doing simple testing. And these are most of the time they're easy to fix unless the data model is correct. But then you know the tricks. And what's worse is if you have concurrency problems. So this also, if you do like JavaScript requests and you don't have really a scheduled time of the application. And when you discover them, usually you can't really fix them. And you just like to have like this web transaction rate, if you do a standard scenario, so my experience, okay, if you deliver statically, you can deliver whatever. But if you have an application behind it, doesn't matter what it is. I think like a rule of thumb is a normal application that's not really tuned or something like this should deliver between 50 and 80 transactions per second in the mix. So this is something not really exciting. If an application then gets tuned, it does it, or it's a fast application, it does 100, 250 per second, and really fast applications to 200, 250 application, not just static delivery. On one node, not scale level. And most of the time when you start, this is like you have like 10 to 15 per second, then you have a problem. But it's about the interpretation of these results. I try like to summarize, but it's a matter of doing enough tests and then you just look at the graph and see like, whoops. And I wasn't really able to put it on one slider, so I just didn't do it. What anecdotes? It's yeah, you have a website, and all of a sudden the website gets linked on one going, and not a question of anecdote. Yeah, if I show you the slides and you see the customer name. So it's like within half an hour the traffic was more than 40-fold. This is something we will never test. But then we use an approach like this just to optimize the application. Not that we wanted to be able to deliver 40-fold, but when we had this huge traffic, we realized that the application could run a little bit smoother.
Surviving September 11th.
I think there's tons of examples like this. One is the famous airline in Switzerland. I don't need to mention names, but I guess you know who. Which after they went rebuilt themselves, they had a new website and it was all cool and shiny. It needed to be finished on the day. And they were so great to tell us that they're going to make a huge ad campaign that on the first day they go online. It's actually the first people who actually get on the website and get tickets. They get very cheap tickets. The website was down for 5 days. No way. So you can load test whatever you want before that. Yes, we did. No way to handle that.
That's actually a cheap load test, you know.
Was that a new airline or an old airline?
That was a new airline.
Or a new version of an old one.
A new version of an old airline, yeah.
Okay, because I have an anecdote of the old version of that old.
Don't tell customer name.
And there was a plane crash, and
oh, yeah.
and my company at that time was doing a website, and they decided to, or they called up the team and they said, hey, what can we do? And they decided to make a plain text version of the homepage with all the necessary emergency information.
Like CNN did on September 11th,
Yeah.
successfully.
Yeah, exactly.
They survived.
The only one, yeah.
And news.search.ch.
But I think this is the whole this is a whole task that about how to make something faster, like performance tuning, or how to get away. For example, you put page elements in a storage array. I don't know, you can put page elements to S3, and you request them from there. You may not get a nice latency, but at least you get enough throughput. So I think this is a talk on its own, how to fix stuff. I just talked to you about how to find out what you could fix. And I think web performance is something we should handle during one day and not during 1 hour.
Okay.
Thank you.
Thank you.
Tom Key